All right, hello and welcome to our project. This is California County's 8th grade enrollment totals and reclassified fluent English proficiency rates. My name is Sophie. I am a psych major and prospective transfer.
Hi, I'm Sachi, and I'm a history major looking to transfer to pre-law.
My name is Shannon. I'm hoping to get into a nursing bachelor's program in the next few years.
All right, so to get into our data, we found our data set through the California Department of Education Data Quest. And this is a data set that shows total school enrollment by counties of all grades and English fluency rates, whether it be reclassified or not. And we sorted this data by putting it into a larger Google Sheet and figuring out the information we needed based on our hypotheses, which we will get into later. We chose this topic because we all shared an interest in educational demographics in our home state, and we wanted to know how the counties differed in number of students enrolled, and also about the variety and distribution of RFEP rates throughout California. And then we created hypotheses that investigated the enrollment size and RFEP rates, which we also get into later, like I said. And to narrow down the data, we focused on the 8th grade classes in the 2018 through 2019 school year. And then in order to get our sample, we took a simple random sample of n equals 13 by treating each California county as an individual in a population of all of the 58 counties. We listed these counties in alphabetical order and then assigned them an ID number of 1 through 58. And then we used a random number generator to choose 13 numbers at random. And we actually had two samples. And the counties for sample 1 was Sierra, Santa Cruz, Del Norte, El Dorado, Glen, Yolo, Humboldt, Butte, Nevada, Yuba, Santa Clara, San Bernardino, and San Francisco. And for sample 2, the counties were Orange, Butte, Fresno, Monterey, Yuba, Sierra, Marin, Imperial, Trinity, Alpine, Tuolumne, Mariposa, and San Bernardino. And now to get into our hypotheses. For null hypothesis A, which focused on the population mean, we hypothesized that for the 2018 through 2019 school year, the population mean of 8th grade enrollment sizes for all of the California counties was 10,000. And for null hypothesis B, which focused on the population proportion, we hypothesized that in the 2018 through 2019 school year, the population proportion of 8th graders in California who were categorized as reclassified as fluent English proficient, RFEP, was 0.2. And now it is time to use the sample data from population 58 counties to test our null hypotheses. And then here we have a graphic that just shows our samples and the counties that they are.
So I worked on hypothesis test A about the population mean of enrollment size of 8th graders in California counties. So like Sophie said, our null hypothesis was that we hypothesized that for 2018-2019 school year, the population mean of 8th grade enrollment sizes for all California counties was 10,000. And our alternative hypothesis was that we hypothesized that the population mean of 8th grade enrollment sizes for all California counties was greater than 10,000. We used the sample size of 13 and the population 58 of all California counties. We set our significance level to alpha equals 0.05. And also from our data, we were able to calculate population standard deviation from all of the counties put together. So here is again, a list of sample 1 data, as well as or the names of the counties, as well as the enrollment sizes for 8th grade in 2018-2019. Here's a histogram of sample 1 counties for not only total enrollment, but also English only, initial fluent English proficient, English learner, and reclassified fluent English proficient students within these 13 counties. So in this bar graph, we this basically helps us conceptualize the distribution, my goodness, the distribution and basically just the differences across counties in enrollment sizes. So I started by calculating VARS 1 stats on the calculator to find the mean of 5,458.69. And from that, we used that mean and the standard deviation of the entire population to calculate the Z statistic from our calculations, which we found where we found Z to equal negative 0.971. And that meant from our table in the textbook that P equaled 0.834. So in hypothesis A from sample 1, using the Z statistic of negative 0.971 and the p-value of 0.834, we find that we failed to reject the null hypothesis because of the p-value being so much larger than alpha, the significance. So that means we do not have evidence to disprove the claim that the population mean of 8th grade enrollment sizes for all of California counties was 10,000 or greater. So I performed a 95 confidence interval for this sample using the mean of the sample and the standard deviation of the entire population. And I found that the 95 confidence interval laid between 2,918.18 and 7,968.19. So this graph of the bell curve shows us where Z value lies in relation to Z of alpha. And that shaded region of Z of alpha basically is where we would be able to decide whether or not we could reject the null hypothesis. So now we're going to use the same exact formulas for sample 2 counties. Here are the counties for 8th grade that were randomly chosen, as well as their total enrollment. Here is a bar chart to help conceptualize the distribution and differences between the counties with their enrollment sizes. And here we can really see how big of a difference some California counties really have in relation to others. In Orange County and San Bernardino, there are more than 30,000 enrolled students in 2018, 2019. But in places like Alpine and Trinity, there are less than 100. So again, here are the VAR stats for sample 2 counties. I found the mean to be 7,820.46. And again, using the same standard deviation of the entire population, I used the Z formula to find the Z value of negative 0.466 with a p-value on the table from the textbook of 0.679. So what does this mean when the Z statistic is set at negative 0.466? And that means we have a p-value of 0.67. Well, when the p-value is significantly larger than the A value, when we set it to 85%, we no longer have enough evidence or conclusive evidence to be able to reject the null hypothesis or the alternative hypothesis. We still do not have enough evidence to disprove the claim that the population mean of 8th grade enrollment sizes for all the California counties was 10,000 or greater. I performed another confidence interval for 95% on sample 2, only basically changing the mean, which was 7,820.46. And this gave us the confidence interval of 5,280.49 to 10,361.507. Again, we can see how separated the Z value is from Z alpha. And again, we do not have enough evidence to reject or support our claim. So putting it all together, from sample group 1 with a mean of 5,458.69 and a p-value of 0.834, and sample group with a mean of 7,820.46 and a p-value of 0.679, we can conclude that both 0.834 and 0.679 are significantly larger than 0.05. And we, again, do not have enough evidence to support our claim, which caused a little bit of an issue within our hypothesis, and we failed to reject the null hypothesis and the alternative hypothesis, but we do not have enough conclusive evidence.
Part 2 of our experiment was to test our hypothesis B. Hypothesis B was about a population proportion of the 8th graders in California that are reclassified as fluent English proficient, or the acronym RFEP. This scatter plot shows dots for all 58 counties. You can tell on the x-axis, the values are how many students are enrolled, 8th grade students, for the 2018-19 school year. And for that same school year on the y-axis, you can see how the proportion of that county's 8th graders that are classified as reclassified fluent English proficient, RFEP. So you can see the really large enrollment county of Los Angeles County way off to the right. And it has kind of somewhere in the middle of its RFEP value. So its RFEP is not the lowest or highest in California, but it has the most 8th graders by far. So our null hypothesis B about the population proportion is that in the 2018-19 school year, the population proportion of 8th graders in California who were RFEP was 0.20. And our alternative hypothesis was that that population proportion was greater than 0.20. So as Sachi explained, and Sophie explained earlier, we had 2 different sample groups, sample number 1 of 13 counties randomly sampled, and then sample number 2, which was a different set. This shows sample number 1, and for each of those counties, what proportion of their 8th grade students in that year were RFEP. So those numbers here in pink show what those proportions were. And the same data in the last slide is shown now on a histogram. The length of the bar shows how high their proportion of RFEP students was in that county of our 13 counties here in sample 1. And I didn't do graphs like this for sample 2, just because I just wanted to show how it can be conceptualized, but without repeating myself too much. Because you kind of get the idea from kind of Sachi laid out how sample 1 and sample 2, we kind of tested each one with in a similar way, but we just wanted comparisons. That's why we did 2 different samples. So here we also have sample 1 data for the second line, but just going down the list here, we have a few different values that are pretty important when we're looking at population proportions and doing tests about them when it comes to like a whole population and then a sample of that. So our null hypothesis proportion, which we talked about earlier, P naught was 0.20. And then our sample proportion for sample number 1, this P hat value was 0.24548. And it was different for sample 2, which we'll get to later. And then for the population proportion, this is actually just a summary statistic. If you're looking at all of California in 2018 and 19, the 8th grade students in all of the whole state, the proportion of them who were classified as RFEP was this number, 0.26638. So we're guessing around this number, this proportion with our hypothesis test and our confidence interval, because we just wanted to do statistical tests and see how it went. But we have access to the actual data, and so we're able to calculate this value of 0.26638. But our educated guess value was this one up here, the 0.20. So just wanting to explain the difference between these different things that have very similar looking variables, P naught, P hat, and P. Okay, so getting into our hypothesis test, our first iteration with our sample 1 data, testing hypothesis B. We calculated a z statistic of 0.40995. We did that by hand using a formula. And then we use that z statistic in Google Sheets. We got a p-value of 0.91. That was larger than our confidence level of alpha equals 0.05. It was larger than it by a lot. So because the p-value is so much greater than the a, we at that 95% confidence level, we fail to reject the null hypothesis. We do not have enough evidence. We're rejecting the null hypothesis because we don't have enough evidence to, we fail to reject the null hypothesis because we do not have evidence to do so. We don't have evidence to claim that the population proportion of those 8th graders who were RFEP was equal to 0.20. So we have to fail to reject our null hypothesis. We also constructed a 95% confidence interval for the population proportion based off of the sample 1 data. So we found that the 95% confidence interval for that population proportion was between 0.24487 and 0.24609. And that's based off of our sample 1 data. It's different from our sample 2 data confidence interval. So we repeated this procedure again, but used sample 2 data. Here are sample 2 counties and their respective RFEP proportions. Our hypothesis test yielded a z statistic value of 0.54786. When we plugged that into Google Sheets software, we got a p-value of 0.99. This was also similar to the first iteration of our hypothesis test on sample 1 data. This p-value was way larger than our alpha equals 0.05 confidence level. Because alpha was so much smaller than our p-value, we failed to reject the null hypothesis again with this different data set of sample number 2. So we can't reject that null hypothesis, and we can't say the population proportion was not 0.2. Our 95% confidence interval based off the sample 2 data was about 0.2607 up until 0.26085. So you can notice going back to our other confidence interval, this is in the 0.24 range based off of sample 1 data, whereas based off of sample 2 data, confidence interval was way different. They don't even overlap with each other. This was in the 0.26 range. So like 24% was the guess for one and 26% was the guess for two. They really don't overlap. So that shows there is a lot of variation in the RFEP proportions of different counties in California. So depending on which sample you take out, it really affects the picture that it paints of the whole state. So we have a very diverse state in many ways, and that is one that your sample, it probably would have been good to take larger samples for a more accurate guess at the major sample proportion of our RFEP students in our state. So I'll hand the mic over to Sophie now to talk about the summary of some of our key findings.
Yeah, so to get into the summary of our key findings, we found that with the 2 samples of 13 counties that we drew from the population, at a 95% confidence level, we could not find conclusive evidence to reject the claim that the population mean of enrollment of 8th grade students was 10,000, and we also nor could we reject the claim that the population proportion of students that were reclassified as fluent English proficient was different than 0.2, which is all the math that Shannon and Sachi went over. And we also found that as the p-value gets closer to 1, the more inconclusive the evidence is to support the hypothesis. So in order to get around that in the future, we would use a larger sample and also choose a null hypothesis that is closer and more accurate to the data. And these RFEP rates do not really seem to correlate with the enrollment size of these counties, which is something that we learned. And another thing to know in the future, some future project ideas for this data set is that we could look how RFEP varies between counties in the same region. And we could look into the fact that, or we could ask if more students get reclassified as time goes on. And with that, we could also do a study that spans across multiple states, which would take into account different demographics, socioeconomics, and politics. And this would provide some valuable insight to see how different states' school systems effectively teach English to students and how they, accommodate with their resources. And we could also take a look at schools' general academic achievement and graduation rates and compare that to the RFEP proportion to see if they have any correlation. Thank you for listening.
Thank you.
Thank you.